Now we will discuss the phases of matter and phase changes. Here we see pictures illustrating the three fundamental uh, phases or physical states of matter: solid, liquid, and gas. We see solid iodine with its shape defined, not changing with it doesn't flow, it doesn't take the volume of its container. Uh, we see in the picture in the upper right bromine as both liquid and gas. The liquid bromine is at the bottom of the container, and filling the volume above the liquid is gas phase bromine, that brown gas. Both the gas and the liquid can flow and can take the shape of their container. The liquid, however, does not fill the volume of the container while the gas does. Uh, in the bottom of the screen, we have iodine and chlorine both as gases in, in their containers, filling the volume, taking the shape. And in the case of the iodine, there's also some solid crystals in the bottom that are of definite shape and volume. One big difference between gases and the other two phases, liquids and solids, is the density. The density of gases are much less than that of solids and liquids. So if we look at water, for instance, liquid and solid water have similar relatively high densities compared to gas phase water. What does this mean? Well, it implies that when you change water from a liquid to a gas, for instance, that sample in its new phase of a gas must have a lot of empty space within it in order to account for the low density. Gases are considered compressible. We can squeeze down on them, and in that case, the density will change. So, in the table that we used for an example, that was a specific sample of water vapor with that density. If we were to squeeze down on it, we could change the density because we're changing the volume and compressing the sample. Solids and liquids, however, are not compressible. They're referred to as condensed phases. They have relatively very little empty space, and they're not compressible, or not very compressible, I should say. So the condensed phases have greater density and low compressibility. Liquids are slightly more compressible than solids, but neither is very compressible compared to a gas. Then we see that liquids are similar to gases in that they're both fluids. They can both flow because they do not have a definite shape. They can take the shape of their containers, they can flow into a container and take its shape. Gases, however, will fill the volume of the container, but liquids will not. They'll take the shape, but they do not fill the volume if there's unless there's enough of it around to completely fill it. So we want to look at the phases at the molecular level and see if we can understand the makeup of the phases at the molecular level, how they differ, and how we can explain these properties. So first of all three phases have particles in motion. The particles in all three phases are moving. They're not still. Uh, Gases and liquids have particles with relatively free movement. The particles can move past one another. In gases, the particles are completely independent. They are not touching one another as they are in the liquid. Solids have particles that do not move freely, but there is motion. So what kind of particle movement is there in solids? Well, you could have vibration. So if you look at that picture of the solid on the right, the particles, the molecules in that solid, those particles cannot slide past one another like they do in a liquid or a gas. They're sort of locked in place in their individual positions, but they can vibrate within the space in which they're restricted. They have a little bit of movement where they can vibrate and move around a little bit, but they can't slide past one another. For solids and liquids, the particles are touching. They're in close proximity. In a liquid, they can still move past one another, but they still touch one another. In a solid, the particles are touching, and other than vibrations, they cannot move very much at all. In a gas, the particles are moving freely past one another and actually independent of one another, not touching. So at the molecular level, we know that gases are compressible, but at a molecular level, why is that? It's because the particles of a gas are not touching. There's a lot of empty space between the particles, and so you can squeeze down on a gas and push the particles closer together. Gases and liquids can flow because the particles can move about. They're not locked rigidly into a lattice of positions next to particles that are also locked in position. Liquids and gases have particles that can move, so they can flow. That also explains why they can take the shape of the container. The particles of gases and liquids can flow, and so when you put them in a new container, they can take that shape. Gases, however, can occupy the entire volume of the container because the particles are independent and not touching one another. In a liquid, the particles are still in contact with one another and do not separate from one another. So they will flow and take the shape of the container, but if the container is bigger in volume than the sample of the liquid, then the volume will not be filled by that liquid. Now let's consider phase changes. A phase change occurs when a substance goes from one phase to another. Here we have some pictures of water, some steam, some gas, solid, ice or snow, and liquid water. So if you change a solid to a liquid, that's called melting or fusion, and the reverse is freezing. If you take a liquid and turn it into a gas, that's called vaporization. The opposite would be condensation, when a gas becomes a liquid. Solid transforming into a gas is called sublimation, and the reverse, a gas becoming a solid, is called deposition. It is important to consider energy changes. When you change phase, you are either going to have to put energy in to accomplish the phase change, or energy will be released during the phase change. So fusion, melting, solid to liquid, vaporization, liquid to gas, and sublimation, solid to gas. Those all require energy. Energy is absorbed. Freezing, liquid to solid, condensation, gas to liquid, and deposition, gas to solid, those three are phase changes in which energy is released. So here's a picture of condensation. Suppose you had a cold glass of water and it's a humid day. There's a lot of water in the atmosphere in the gas phase. What's going to happen? Well, you're going to see on the outside of glass some water form, and that water in the liquid phase came from water in the gas phase. So the cold glass surface had water condense onto it out of the gas, the atmosphere around us. At the molecular level, how would you picture this? Well, in the gas phase, in the air around the glass, the water molecules in that air are in the gas phase and they're independent particles you see here in this picture. When they condense, they become a liquid. And so now the particles are touching one another. They're not very orderly like you'd see in a solid, but they're touching one another, but they still have a lot of disorder in the picture where the particles can move past one another and flow. You can also look at phase changes on the molecular level. We have the gas, liquid, and solid pictures of the substance at the molecular level in the three phases. And any phase change that requires energy is one that is giving more freedom of movement to the particle. So if you take a solid in which the particles, the molecules or the atoms of the substance are locked rigidly into a nice orderly crystal, and you melt it, turn it into a liquid, the particles have overcome this restriction that they have in the solid and gain some freedom of movement. You have to supply energy for that to happen. So that requires energy. Likewise, to go from a liquid or a solid to a gas, you have to put in energy to pull the particles apart. Something was holding them together, making them remain in contact with one another. To overcome that, you need to add energy to separate the particles. In one direction, you add energy. In the opposite direction, energy would be released. So if you were to go from a gas to a liquid or a solid to become a phase that has less freedom of movement of the particles, you would release energy. Going from a liquid to a solid, you would also release energy. So that is how we picture phase changes at the molecular level.